In this next question, we have a logo, and this is going to be a trick question. It's a rectangular logo with a couple of parts of a circle cut out. It's not drawn very well in this diagram, but it looks better on the actual exam. Okay, so there's a rectangle that measures 4 by 5, and we have another picture of it here. The points A and B lie on a circle with center O, so that's a segment, a part of a circle with radius 2. Everything is shown here, right? So it says in part A, find the area of one of these shaded segments. A very popular IB question to find the area of a segment. And it's always area of the sector. Subtract the area of the triangle right here. It gives you the shaded area. Okay, so that area is going to be, the area of the sector is half r squared theta, always in general, right? And the area of the triangle is always half AB sine theta. These are both formulas in the formula booklet. But in the case of these little circular segments, well, in this case we got, well, actually let's factor this out first. Okay, actually let's rewrite this as half r squared sine theta. Okay, because the A and the B are the sides of the triangle and they're both r. And you can actually factor it out to get this. Okay, this is a general formula for the area of a segment. In our case, the r equals 2, and we don't know the theta, so we just write it like this, which equals 2 theta minus 2 sine theta if you expand the brackets. Okay, that's part A. Part B says, given the area of the logo is 13.4, find the value of theta. So the logo, remember, is this. It's the whole rectangle minus 2 of those segments we just found the area of. So the whole logo is going to be 5 times 4 minus 2 of the segments equals 13.4. So we need to solve that equation. And it's paper 2, so we can use a calculator and just type it in and solve for theta. So we can type in 13.4 as a function, and then this here, 20 minus, yeah, this exactly like that. Make sure we're in radian mode, and if we want to manually adjust the window, we go to shift plot. Make sure your y value goes to above 13.4, so it's 15, and this is an angle in radians, so you don't need to go too high for the angle in radians. I did 0 to 5. Click plot. We can see a point of intersection, so that's going to be our answer there. Go to menu, function, intersection, and we get 2.36. Okay. From that we get theta equals 2.36. All right, let's just draw a sketch to show that we actually graphed it. So we got 2.36, just in case we get the wrong final answer, we get a method point here. So the angle is 2.36, let's go back and check. The angle has to be between 0 and pi, and that's correct, that's an angle between 0 and pi because it's less than 3.14.